MTD CNC, bringing you the latest engineering news, reviews, events and special offers via video media.
So Keith, we've got a CMZ TA20YS here. This is a gantry loader. What's the process?
This is a tremendously flexible machine that Empire have got here. This can be hand loaded. As you can see, it's also got the gantry on the top, and on the far end of the machine here we've got a bar feed. So we can input the parts into the spindles by either through the bar feed, billets through the gantry loader, or we can hand load them themselves. And then to exit the parts, we can bring them out through the parts catcher down here, or back onto the stocker, which we'll have a look at in a moment, or indeed you can hand unload them.
So it's an interesting concept, a very interesting concept. Who's going to buy this type of machine?
Well, Paul, there's a popular misconception that gantry machines are for high volumes. That really isn't the case these days. The gantry system here on the CMZ machine is designed to be extremely quick and easy to set up. Most companies run this machine by hand loading during the day, small volumes of parts, because subcontractors have a big mix of stuff. So what they'll do is towards the middle of the afternoon, they'll find themselves a long running job from their production schedule, and they will set the machine up to run unmanned when the guy goes home at 5 o'clock.
So it's not fair of me to say it's just for production, this machine?
No, you can use it, as we said a little earlier, hand loaded or with the bar feed as well. It's a very versatile bit of kit.
Okay, so we mentioned production, lights out machining. What is the machine equipped with to enable you to do that successfully?
Okay, well, in terms of the parts, we've got a high volume or high capacity bar feed on that end, so it's important to have enough capacity to run the machine. On the far end of the machine behind us, we've got a stacker that's got 14 pallets on it, so we can put a lot of billets there. But whilst the machine's running, we've actually got things like tool monitoring. That tool monitoring will look at the condition of the edges of the insert and detect whether it becomes worn or indeed broken. If that tool becomes worn or broken, then we can change to a sister tool so that the machine can carry on. Also, we have coolant level monitors, and once the machine has finished its batch, it will completely shut itself down. So it's very eco-friendly. It won't be running any electricity at night.
All right, that's great. So as a production machinist, you can be assured that you're going to come in to finish parts in the morning and to the required accuracy as well.
Pretty much, yes. We can also fit a Renishaw tool probe on the turret as well. So if you want to measure the parts while they're in the spindle, then you can do that as well.
Okay, so the principle of the machine can be batch work, but also smaller batch work that you can load with the gantry itself. What I like about looking at the machine is actually everything's integrated. So this is CMZ through and through.
Yeah, we designed and built the gantry in our factory in Spain, and all the software has been written by our engineers. There's no programming on the gantry whatsoever. It's all pictorial. All you have to do is give it some parameters, very simple things like the length of the raw part, the length of the finished part, the depth of the chuck jaws, the depth of the gantry jaws, and the program will sort everything out, load it and unload it fully automatically.
That's interesting, Keith, because that was actually going to be my next question. Looking at the machine itself and the gantry, there's a lot of axes moving around, and as an engineer or machinist you might think, well, it's going to be quite difficult to program, control, but it's quite simple. So let's have a look.
Okay, Paul, well, it's very easy to do. If we come onto the loader path here, we can see pictorial. We've got a representation of, on the left here, the raw billet, and on the right we've got the finished billet. So it's very simple. We've got 6 parameters here, and we just input them. So we can see here that the length of the raw part is 12 millimeters, and it's going to finish at 10. So that will tell the gantry what position to go to load the part and unload the part when we take them in and out of the chucks. So onto the second page, and the second page is showing us parameters to do with the stocker behind me. And then here you can choose whether the part goes into the main spindle first, transfers to the sub spindle, or maybe you want to start in the sub spindle and transfer back. So there's lots of pages here where you can set up the stocker and the gantry loader.
And it's your own, this is CMZ software?
This is written in-house at CMZ. Once you've done this, you only need to give one M code in the main machining program, and that tells the gantry to come and change the parts.
So it's dead straightforward. There's no having to write G codes. It's all managed and handled within the software.
Exactly.
So that's great. We've seen the outside of the machine, the gantry, the loading and the unloading. Let's explore inside the machine. You know, this is a sub-spindle machine with driven tools and a Y-axis.
Yeah, absolutely right. This is the TA20's got a 65mm bar capacity on the left, integrated spindle motor, 22 kilowatts. On the sub-spindle here, this is a 15 kilowatt spindle, also a direct drive integrated motor. The turret's a 12-station turret, designed and built by CMZ. Quite a nice, powerful design. 12 kilowatt driven tool motor. The Y-axis is quite big, generous as well. It's -50 plus 60 millimeters, so 110 millimeters on the Y-axis. Also, we've now got 12,000 RPM driven tools on this machine, which is hugely bigger than we've had on the previous models. This, for people doing light alloys, has brought tremendous increases in production with this type of spindle. All of these driven tools now can have a through coolant as well, so if you need to use the special drills with coolant feed through, we can use that with these tool holders as well.
Okay, inside the machine, brilliant. So then we've also, I know it's got a parts conveyor here as well and a parts bin.
Yep.
So whether we're putting into the stocker at the back, or we can also put into the parts catcher here and out on a conveyor.
Yeah, exactly. Yep. So typically when you use the bar feed, you would bring them out onto a parts catcher. The little conveyor down here is really so that as soon as the parts catcher goes onto the conveyor, it moves on a little bit, so we're not getting part-to-part contact. The box in here is fully lined with nylon as well, so once again, protecting all the parts that are coming out of the parts catcher.
I have now built a very strong argument as an engineer as to why I could buy this machine to myself in this short period of time. And a lot of it comes around to having the edge. Would I be right in saying that by having a machine like this, your customer that buys it could have the edge over their competition because they've got so much flexibility?
Absolutely, yeah. Every engineering company, small or medium size, is looking for the edge over their competition. That's exactly what you get here. Because of the unmanned machining hours, it means that you can reduce your labour costs because the machine runs unmanned at night. And if you're looking for that edge, a gantry is the thing to have a look for now.
So the complete flexibility is very evident. I can bar feed and a finished component can go onto my parts conveyor out of the parts catcher. I can also take components from billet and put them in from the stocker and out into the stocker as well. How much is it going to cost me, Keith, if I'm looking at this compared to maybe buying two lathes? What's the difference?
Okay, well, to add a gantry to a machine like this is in the region of £60,000 to £70,000. It may seem like a lot of money. A lot of people would say, I could buy another lathe for that. But if you look at it over the payback periods, then most of our customers are finding they're getting payback between 18 and 24 months. So it really is a good investment. And this is something that will last 20 years.
And are you seeing a trend towards companies looking at this as a
very much so. Every year we're selling more and more gantry machines. The companies that are forward-looking are looking for that edge, and that's what they get with this machine.
So we see the automation here on the TA20, but what about if I was looking for maybe a bigger machine? So on your 25 or your 30, can you apply all the same gantry to that?
Yes, absolutely. Yeah, we could have a TA30 or a 35 and go up in size. The biggest size of billet that the stocker will accommodate is 280 millimetres. There's also a weight restriction as well. That's 10 kilos. So we can pick up 2 times 10 kilo billets. So we like to bring two parts into the machine, bring a raw part in and take a finished part out. So at some time during the cycle, we've actually got 2 10 kilo billets on the end of the arm. If you're prepared to have a single billet, then we can move up to 20 kilos. So we get a much higher weight carrying capacity, but at the expense of a slightly slower loading time.
So this machine is one example of a few models, so you can basically get bigger. It's just really dependent on the weight of the component.
Yeah, the weight of the component. Yeah.
Looking to load. We like talking about footprints at MTD because we know how important it is to engineering companies. You know, floor space is a premium. This is very compact.
Yes, it is very compact, especially when you compare it to a typical robot type cell where you'd have to have 2 lathes back to back to each other with a robot in the middle and then the peripheral guarding all around the edge. It does take up a huge amount of space. As you can see with this one, it's quite compact. One of the other advantages over the typical two lathes and a robot is that it's very easy to change things on the control system. You want to change an offset, you don't have to go into the cage in order to do that.
So with this machine, you're obviously going to produce swarf. I see in here the conveyor actually goes out the back of the machine and not the side.
Yeah, absolutely. Well, it needs to, because on this particular machine, at the right-hand end of the machine, we've got a stocker. So the swarf goes out the back and exits towards the back of the machine, where you can put your normal swarf bin.
I'm going to ask you one more question about, we've got a parts conveyor here, but just behind you to the right, there is another kind of parts bin. What's that for?
Okay, if you're running a batch during the day and you want to keep an eye on the parts, the size of the parts, you can program the machine to bring out every 5th part, 10th part, or whatever you like, and it'll drop one occasionally into the parts checker here. Then the operator can get the parts out and check it with a micrometer or vernier, whatever he likes, and then just be assured that the machine's actually making parts to tolerance.
So I'm going to put you on the spot a little bit here, Keith. Who wouldn't buy a machine like this?
Not many companies, I don't think, Paul. I think most small and medium-sized engineering companies could benefit from having a machine with a gantry on. If any of the owners of those companies just like to think about how much time they could gain by having an extra shift or extra half a shift after the guys have gone home, it would be very beneficial to them. I suppose if you took a company that had very small batch sizes and very short cycle times, then we're going to run out of capacity of storage on the stocker or the bar feed. So maybe it's that type of company that wouldn't benefit from a machine like this.
Well, Keith, it's been a real education today, and I've learnt a lot, so thanks for your time.
Thank you very much.
For more videos, products and news, go to mtdcnc.com or follow MTD Online on Twitter.